In this video for Positive Maths, we're going to learn about surds. So let's just discuss rational and irrational numbers. First of all, rational numbers. They are any number that can be written as a fraction. So we want to note that the decimal equivalent of a rational number, it either terminates or it recurs. So then getting on to irrational numbers. These are decimal numbers that are never ending and non-repeating. So they don't terminate and they don't recur. They cannot be expressed as a fraction. So if a number does not have an exact square root, a perfect square, then it is an irrational number. So some examples: pi, the square root of 2, the square root of 3, the square root of 5. You'll notice we didn't include the square root of 4 because we know the square root of 4 is 2, which is a perfect square. So getting on to surds. A number written as a square root is written in surd form. So examples: square root of 2, the square root of 8, the square root of 13. You could list an infinite number of them. We need to be able to perform operations on numbers in surd form. So these operations are addition, subtraction, multiplication, division, and so on. In order to do that, we need to keep the following two rules in mind. So the first rule: if we have a product, so the square root of AB, we can break this up into its factors. So the square root of A multiplied by the square root of B. So our example is the square root of 8. We can break this up into the square root of 2 multiplied by the square root of 4. Let's take another example. We have the square root of 16. This can be broken down into the square root of 8 multiplied by the square root of 2. Or it can be the square root of 4 by the square root of 4. If we take the square root of 18, this can be broken down into the square root of 9 by the square root of 2, or the square root of 6 by the square root of 3. Our second rule, it's very similar. If we have the square root of a fraction, so a over b, we can break it down into the square root of the numerator divided by the square root of the denominator. So our example, the square root of 4 over 3. This is equal to the square root of 4 over the square root of 3. We can also use these rules to write surds in their simplest form. So let's discuss this. The square root of 8, like we saw before, is the square root of 4 by the square root of 2. We can then simplify this down to be 2 times the square root of 2. This is the square root of 8 in its simplest form. Okay, so let's work on breaking down the square root of 90 into its simplest form. So we can rewrite this as the square root of 9 by the square root of 10. I've chosen this because I can find the square root of 9. It's a perfect square. So that will simplify to be 3 times the square root of 10. Let's discuss addition and subtraction. We can only add or subtract surds that have the same irrational part, or the same square root part. So the rules for addition and subtraction are very similar to the rules for addition and subtraction in algebra. So we can only add like terms. So the square root of 2 plus the square root of 2 is going to give us 2 times the square root of 2. Twice the square root of 3 plus 3 times the square root of 3. This is equal to 5 times the square root of 3. So similar to 2x plus 3x equals 5x. Okay, our third example. 5 times the square root of 6 minus 4 times the square root of 6 is going to give us the square root of 6. Minus the square root of 7 plus 3 times the square root of 7 is going to give us twice the square root of 7. So what do we do when the surds are not the same? Let's go through an example. We have the square root of 2 plus the square root of 8 plus the square root of 32. Okay, what we need to do is simplify every term so that it will be something we can add. So the square root of 2 will stay the same. Square root of 8 is going to change to square root of 4 by the square root of 2. And the square root of 32 will simplify to be the square root of 16 by the square root of 2. Okay, we can see in the next line that we have found the square root of our perfect squares. So we have square root of 2 plus twice the square root of 2 plus 4 times the square root of 2. Now we can add the terms because the third part is the same. So we find that this will simplify to be 7 times the square root of 2. So step 1, we rewrite the surds so they are all in terms of the same irrational number. So that's the square root of 2 in this case. For step 2, we add the surds together. And step 3, we give the answer in its simplest form. Now on to multiplication. When multiplying surds, we must multiply the rational and the irrational parts of the numbers separately. Okay, so an example. We have the square root of 2, square root of 3 by the square root of 2 by the square root of 5. Okay, so this is going to be the square root of, like our rule said, 3 by 2 by 5. So it's going to be the square root of 30. The next example, 2 multiplied by the square root of 5 multiplied by the square root of 3. So this will be 2 by the square root of 5 by the square root of 3, which will give us twice the square root of 15. Now we have 3 by the square root of 2 by 5 by the square root of 8. So we're multiplying all of these terms together. So we'll multiply the numbers. 3 by 5 will give us 15. And if we multiply our surds, we'll get the square root of 16. So this will give us 15 multiplied by 4, which will give us 60. So let's look at an exam question. This is from the 2013 Paper 1, Question 1. We need to use the properties of surds to show that the square root of 98 minus the square root of 18 plus the square root of 2 simplifies to 5 times the square root of 2. So we need to do our first step. We need to change all of the surds so that they are in terms of the square root of 2. 98 will change to be the square root of 49 by the square root of 2. That will be minus the square root of 9 by the square root of 2 plus the square root of 2. So now all of my terms have the square root of 2. The next line is going to be 7 by the square root of 2 minus 3 by the square root of 2 plus the square root of 2. So 7 minus 3 is going to give me 4 plus the square root of 2. So my answer will be 5 times the square root of 2. So therefore I have shown that it does simplify to be 5 times the square root of 2. For more information, visit www.PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.